To determine the force exerted during a thrust engine, wherein you're changing the momentum, take an air blower. Now first, assume that all the air is coming out in a perfect cylinder such as this. Now all of the tiny air particles in the cylinder, each one is going to have the exact same velocity, but what's important is that the masses are different. So write that the change in momentum is equal to the force times the change in time, and you can separate this as the force is equal to the change in momentum over time. And here the change in momentum, because the velocity is going to be equal, we can put that on the outside. And now we need to find the change in mass over time. So in order to determine the change in mass, remember that mass is equal to the density times volume. So what would be the volume? Well, now we can use the perfect cylinder. So let the cylinder's volume be the amount of air displaced in 1 second. Well, if the amount of air displaced in 1 second, that means the length would be, in this case, it would be v, because let's say v was like 2 meters per second. Then that means this would be equal to 2. And then just let this be the cross-sectional area A, and just let this be R. So therefore, v is still on the out. The change in mass would be the total area, and the area is equal to pi r squared h. So it's equal to pi r squared times the velocity over time. And and reminder here that time is equal to 1 second, because from here, so it's just equal to 1. So therefore, the force is equal to pi r, times a. Don't forget about a. A is just pi r squared. So pi r squared times, don't forget about rho, times rho v, which is equal to rho a v squared. No, it's v squared because of this.